Good morning, doctor, and I'm going to talk about ocean ion fertilization. Ion fertilization defines as the introduction of iron either naturally or intentionally into the ocean surface to stimulate the phytoplankton growth. The atmospheric gas composition in the ancient time is studied with the analysis of trapped air bubbles in Arctic Antarctic ice cores. It is found that the atmospheric carbon dioxide in last glacial maximum was much lower than during pre-industrial time. Martin measured the iron level in seawater collected from different regions and found that the concentration of high nutrient and low chlorophyll waters were low. He then came out with a hypothesis about iron has a role in the photosynthesis rate. Ocean ion fertilization is aimed to test Martin's hypothesis. Reducing the atmospheric carbon dioxide by increases the biological carbon dioxide uptake as iron acts as an essential micronutrient to stimulate the uptake of macroplankton for phytoplankton growth. Ion fertilization has been carried out in high nutrients and low chlorophyll other than low nutrients and low chlorophyll regions. High nutrients and low chlorophyll regions include equatorial Pacific with high light intensity and temperature which would promote rapid phytoplankton growth. Southern Ocean where is the largest high nutrients low chlorophyll region in the ocean world, and subarctic North Pacific with strong longitudinal gradients in alien dust deposition, where high dust deposition in the west but low in the east. Meanwhile, low nutrients, low chlorophyll regions include subtropical North Atlantic, where primary producer is predominant by nitrogen fixers. Based on the finding, iron has the function to stimulate the uptake of macronutrients for phytoplankton growth. Thus, when the concentration of iron increases in a region, the photosynthesis rate in that region increases, taking more atmospheric carbon dioxide to undergo photosynthesis. Hence, the atmospheric carbon dioxide is reduced. There are 19 ocean ion fertilization studies in total, with 6 natural ocean ion fertilization and 13 artificial ocean ion fertilization performed in the subtropical North Atlantic, equatorial Pacific, subarctic North Pacific, and Southern Ocean. For artificial ocean ion fertilization, there are 2 studies carried out in equatorial Pacific, 3 in the subarctic North Pacific, 7 in the Southern Ocean, and 1 in the subtropical North Atlantic. The method used to track and quantify carbon export flux in the experiment is one of the causes for the unsuccessful finding of the study. The possible negative effects of the ocean ion fertilization and the international artificial ocean ion fertilization experimentation laws are also limiting the study. All the experiments carried have achieved their main aim on the testing of Martin's hypothesis about the ion limitation control the concentration of the atmospheric carbon dioxide, and are considered success to remove carbon from the atmosphere other than increase the carbon sequestration. The experiment can be further improved in several aspects. For example, the location, timing, and the duration of the experiment. Based on the previous study, dominance of diatoms in the phytoplankton communities are usually found after the adding of the iron. Meanwhile, the silicate concentration and mesozooplankton stocks, such as copepods, are the factors affecting the size of the diatom blooms. Thus, the experiment should be carried out in the region with high silicate concentration and low grazing pressure. For the timing and duration of the experiment, it was found that the primary production in ocean is affected by nutrients and light availability. Thus, early summer time is likely to be the best timing for the experiment. From the reading, a duration of the experiment should be more than 40 days to cover the full response times of a phytoplankton bloom from onset to its termination. Some of the methods of the experiment should be detailed. The method of adding and maintaining dissolved iron within the mixed layer was suggested to be slow and continuously to prevent substantial loss of artificially added iron. Minimum 2 or 3 iron infusion at intervals of 10 to 15 days was suggested. For the method of tracing the fertilized patch and the detection of the carbon sequestration, combination of multiple methods is suggested to detect particulate organic carbon produced in response to an iron addition. Neutrally buoyant sediment trap (NBST) system and water column based torrent 234 method combined with autonomous sinking particle profilers of a transmissometer and an UVP to provide continuous quantitative and qualitative information about the sinking particles.